Hi everyone. Today we'll discuss Leibniz theorem on alternate series. What is an alternate series? The term alternatively positive and negative. Positive, negative. First term positive, second term negative. Third term positive, fourth term negative. Fifth term positive, sixth term negative. Like that. It goes on and on. So how if the condition is there, it should be an alternate series and un is greater than 0 for all n converges if un is greater than un plus 1 for all values of n, and then limit n tends to infinity un equal to 0. Then the series is said to be convergent by Leibniz test. Okay, we'll do one problem. We'll go by few problems to clear the concept. So problem number one 1 minus 1 by 2 plus 1 by 3 minus 1 by so on. So first the series should be alternating. It is an alternating series. First, what is un? 1 by n. What is un plus 1? 1 by n plus 1. So n is less than n plus 1 or 1 by n is greater than 1 by n plus 1. So that means un is greater than un plus 1. So un is greater than un plus 1 for all values of n. Now limit n tends to infinity un. Limit n tends to infinity un. What is un? 1 by n. 1 by n is 0. So by Leibniz test, un is convergent. Convergent. One more problem. Suppose 1 by log 2 minus log 3 plus log 4 log 2 minus 1 by log 2 minus log 3 plus log 4 minus plus goes on and on. So what is our un? Un equal to 1 by log n. 1 by log n. So what will be un plus 1? 1 by log n plus 1 by s. So un is greater than un plus 1 for all values of the n. The limit n tend to infinity un equal to 1 by infinity. Log infinity is infinity. 1 by infinity is, you see, log infinity. Log infinity is infinity. 1 by infinity is 0. The rule says we should not write like this. Just we have to say orally. So therefore, limit n tends to infinity un equal to 0. 1 by log n 0. Therefore, by Leibniz test, the given series is convergent. One more example. So one I have done plain, one I have done with the log. Now one I'll do with the trigonometry. So summation n equal to 1 to infinity cos n pi by n square plus 1. N square plus 1. So here un equal to cos n pi divided by n square plus 1. Cos n pi is what? Minus 1 to the power of n by n square plus 1. So un is greater than un plus 1 for all values of n. Now the first condition of Leibniz theorem is over. The second limit n tends to infinity. Limit n tends to infinity un. 1 by n square plus 1 equal to 0. This, you see, this minus 1 to the power of n is for alternating. The series is just 1 by n square plus 1. So the series is convergent. Therefore, the series is convergent by Leibniz test. One more problem. Factorial 1 minus 2 factorial plus 4 factorial 1 by 6 factorial, so on, so on. So what is un? Un is 1 by 1 by, you see, even number is there, so 2n plus 2. So un plus 1 is 1 by, next term is 2n plus 4. So un is greater than un plus n for all n. Now limit n tends to infinity, un equal to 0. Therefore, series is convergent by Leibniz test. Convergent by Leibniz test. So this we have done. So one more. 1 by root 2 plus 1 minus 1 by root 3 plus 1, 1 by root 4 plus 1 minus plus so on, so on. So what is our un? It is an alternating series. Un is 1 by root of n plus 1. So un is greater than un plus 1 for all values of n. Therefore, limit n tends to infinity, un equal to 0. Therefore, the series is convergent by Leibniz test. By Leibniz test. So next 1.2. 1.2 minus 3.4 plus 5.6 minus plus so on, so on. So the series is alternating series. Un equal to 1 by 2n minus 1, 2n plus 1. This is odd series, 1, 3, 5 odd numbers. This is even numbers. 2, 4, 6 is an even number. So 2n plus 1, 2n minus 1. Or I can take, or if you want, you can go by this also. The first series, the red one. Let me go with the red one. 1 plus 1 minus 3 plus 5, so on, so on. No, take plus only. A equal to 1, D equal to 3 minus 1, it is 2. So what is T n term? A plus n minus 1 into D. First term is A, n minus 1, D is 2. So this is 2n minus 2, this is 2n minus 1. Then another one is 2, 4, 6. Another series is going. Another series is. So you see, I have done a complete video on progression. You can see that. A equal to, this is arithmetic progression. Difference is 2. So what is T n terms? A plus n minus 1 into D. So 2 plus n minus 1 into T. So this is 2n minus 2 plus 2 getting cancelled, 2m. So our series will be, so this we have done. So our un is 2n minus 1 into 2n. And so un is greater than un plus 1 for all n. So limit limits limit n tends to limit n tends to infinity, un equal to 0. The series is convergent by Leibniz test. So one more example, then we are done. So summation minus 1 to the power of n by n sine 1 by n. So what is our un? Minus is there, minus 1 to the power of n is for alternating series. What is un? 1 by n sine 1 by n. So what un plus 1? So un is greater than un plus 1 because denominator is increasing for all values of n. So now limits n tends to infinity un, limit n tends to infinity 1 by n sine 1 by n. Please see here. Please see. 1 by n, 1 by infinity is 0. And this is what is the range of sine? Range of sine is minus 1 to plus 1. So it is a fixed quantity. 0 into any fixed quantity is 0. I want to say it is not undefined. That's the meaning. So limit n tends to infinity, fixed quantity 0 into fixed quantity is 0. Therefore convergent by Leibniz test. Convergent by Leibniz test. So thanks for watching. Please subscribe my channel for more upcoming videos, and please let me know which topic you want me to discuss. And for improvement of my channel, please let me know what are the topic you want me the way. Thanks for watching. Thank you once again.